Welcome to Mr. Brown's Basement, a channel devoted to sharing the craft of repairing, restoring, and modifying vintage electronic gear, and other random stuff.
This video is about a TeleConcepts telephone I picked up recently in Elmwood, Canada. I thought it was a one-of telephone, perhaps assembled by a hobbyist, and that it would be easy to get up and running. I was both wrong and very wrong at the same time. TeleConcepts was a manufacturer of unusually styled landline telephones in the 1970s and 1980s. Back then, everyone had one or more landlines in their homes, and no one had cell phones. That could be because the first cell phone didn't become available until about 1984 and cost almost $4,000 at the time. Most landline phones were styled to be usable and durable, though there was a growing market for novelty phones and novel designs. That's where TeleConcepts fits in, except their phones went a step or two beyond novelty and made it most of the way to strange. Here are some links if you want to see some of their wild designs. The thing about TeleConcepts phones was that many were so off the wall that people often thought they were one of a kind rather than a commercial product. That they used plastic identifier labels, which routinely fell off, fed this idea. My TeleConcepts phone has no identifying marks on it at all and has very distinctive styling. The case and cradle appear to be made of solid stained oak with a marble face. The number pad has white buttons with a black glossy surround. The receiver, however, is completely ordinary. On the front there is an angular plastic projection which appears to be a visual indicator. I expected to open it and find the usual telephone guts: a hook switch for the receiver, a coil network, a bell ringer, and a touch-tone dialing module, all neatly wired together. What I found was something more akin to a botched transplant experiment intended to create a monster. Having never been in a TeleConcepts phone before, I didn't know exactly what kinds of parts they used, but this didn't look right to me. I don't think this is original because they used a Robertson screw, and that's not something you typically see, where everything else is either flat or Phillips. The circuit is designed to power the speaker, so it's some sort of ringer. These two ICs are Motorola 1455s, which are exactly the same, pin for pin, as 555 timers, and 4 bipolar transistors. It's made by Northern Telecom. We have 2 output wires to the speaker, and we have 2 input wires, which would have to be power. I could deduce the polarity from this thing here and see what sound it makes, if any. Applying power to the board did nothing. I know from my experience with 555 timers that pin 1 is ground and pin 8 is VCC. So I should be able to apply power directly to one or both of those ICs and get some action happening. I'm going to give it 5 volts. 555s can certainly handle 5 volts. Ground and pin 8 is VCC. Well, there you go. That is what the ringer sounds like when power is applied directly to the chips. Off with the duct tape holding the speaker to the bottom plate, and I don't think this 180 ohm resistor is what they do in the factory. And leave part of another wire. And this is the bottom of whatever indicator is in the corner. It's not even connected up. I'm going to give it 1.5 volts and see if it lights up. It's taking about 50 milliamps at 6 volts. There's an incandescent light in there. I took apart the wiring block, and the only 2 wires that are connected are red and green, which are the 2 you normally use for telephone. All these other wires are wound up like this, but if you go into the telephone, many of them are connected. This is a single line telephone. There should only be 2 wires connected. All these other things go to that mess and don't do anything at all. I took the electrician's tape off in the connector block. The wires, some of them are just tied together. I've had a chance to trace out some of the circuit. So we have line going to the coil and to the dialer as expected. but there's sort of some cross thing going on here. I don't know why, probably a mistake. The terminal strip is a power supply for a 12-volt relay. All the contacts, the read contacts, are wired in parallel, and power ringer. So it could not possibly have worked in the condition it was in.
What I really need is a diagram of the coil network so I can figure out how to reconnect some of these wires. Since several manufacturers supplied parts to TeleConcepts, it's hard to know where to start. This is the dial module. The chip on it was made by Microsystems International and has a date code of early 1973. There's no information about this chip online. The module has about a dozen wires coming from it. There's no possible way they're all needed. This is how the coil network was wired. Without more information about it, I'm stuck. The phone sat in a box for about 2 months while I searched for information and found nothing. Well, that's it then. I hope you enjoyed watching this video from Mr. Brown's Basement. Please like and subscribe. Only kidding. There's more to the story.
After pulling out the network from the telephone, I noticed an identification on it, NE425QE1, which has led to the schematic and a typical application. Now to figure out what's going on with this dialing module. There were some wires added that had nothing to do with normal operation. Somebody's afterthought, and I've just cut them off. Now all these other wires, I don't know what they are yet, but I'm going to figure out what they do and where they should go in the phone. I've already determined that these wires, these black and white wires, come from this read relay, and they are normally open until something pulls that relay shut. I've spent time tracing through this circuit. It's not easy because the two boards are connected together and I would have to disconnect them from one another. Not quite sure I want to do that yet. We have this section here which creates the DTMF tones, and it's impressed on the input voltage. And we have this section connected by an opto-isolator, which closes this relay when nothing is depressed. When something is depressed, then those contacts open. Also, it seems that whoever was playing with it before disconnected the asterisk and pound buttons. They don't do anything. There are the switches with the purple and the gray wires that don't belong. I don't have much choice but to separate the two boards and see what they did to the printed circuit board. What it looks like the previous owner did was they cut this trace there, which disabled this button, and they cut this trace over there, which disabled this button. Clearly they had another thing in mind for these two buttons. I've put in a total of 6 jumpers, which will fix everything that had been removed. The ringer circuit that I found in this telephone, I don't think it's the original. I don't think I'm going to use it.
How I wired this up may be tedious for some. You may wish to skip to the next section. The two wires that connect to the central office are tip, usually the green wire, and ring, which is usually the red wire. They are connected to terminals L1 and L2 respectively. L1 and L2 are just tie points on the coil network. Normally, the 2-bell ringer coils would be connected across terminals L1 and L2 with a DC blocking capacitor located inside the coil network at terminals A and K. This capacitor allows AC ring voltage to activate the bell while also preventing the low impedance bell coil from drawing any DC. I'm not going to be using any ringer. I'm just going to use a visual indicator. Instead of the incandescent lamp, I'm going to use a neon lamp with a current limiting resistor. Between L1 and L2 and the transformer in the coil network are 2 sections of the hook switch. They are closed when the phone is off hook so that the transformer in the coil network will not see the ringing signal when the phone is on hook. The coil network's transformer connections are at terminals RR and C. When the phone is off hook, terminals RR and C receive the off-hook DC voltage, which is 4 to 6 volts. This goes to the dial module's tone generator, red and green, and to the dial module's relay driver, blue and yellow. The receiver's microphone is connected to terminals B and X. X is just a tie point. The receiver's earpiece is connected to terminals GN and Y. Y is also just a tie point. Finally, X and Y are connected to the relay contacts on the dialing module. The contacts are shunted by an RC filter, which will partially mute the dialing sound to the earpiece when the contacts are open. The contacts are open when a number is pressed on the number pad.
I've put it back together and cleaned it up. It looks nice. Looks nicer with new green felt on the cradle. It's a matter of going to find a telephone receptacle to plug this into to give it a test. The answer is it dials out very well, but when somebody dials in, the neon light right there doesn't light. And I can either attribute that to a dead neon bulb, unlikely, or that the ringing voltage from my optical network terminal isn't high enough. I'm sure if I put it onto a plain old telephone system, it would work just fine, but I don't have one. I'm either going to have to change the bulb out for another bulb or a smaller resistor, or maybe even improvise an LED. Not happy with the neon bulb, it doesn't work. So I took out the neon bulb and I put in an LED, a warm white LED, and a full wave bridge. I'm going to use a capacitive dropper, 0.5 microfarads, with a bleeder of 470K. The ringing LED works properly now, but with a bonus, or a bug, depending on how you look at it, that 470K resistor should have been higher because I'm getting leakage through that resistor, just enough to cause an LED to glow. Well, if I don't like it, I'll change it to a bigger resistor, and if I like it, I'll keep it.
I hope you enjoyed this video from Mr. Brown's Basement. It would be very helpful if you clicked the like button and also subscribed to my channel to be notified when new videos come out. Don't forget to leave your comments. As always, thanks for watching.